All right, one more really quick example here. Maybe not as interesting as the Lando example, but maybe a little more practical for something that could happen in real life. A nuclear reaction occurs with a half-life of 1.2 times 10 to the negative 6 seconds in a particle accelerator where the particles are traveling at 80% the speed of light. What would you expect the half-life to be if the particles were at rest? So this time, you have to imagine I'm watching these particles have this half-life, so I'm not moving. So the time of the observer is 1.2 times 10 to the negative 6 seconds. The speed of the objects is 0.8 c. And the question is, what is the actual time for this process? And if you're in the frame of the particle itself, how long would this take? Or if the particle was at rest, how long would this take? The equation here is that the actual time is going to be equal to the observed time times that factor. So if I observed it to take 1.2 times 10 to the negative 6 seconds for a half-life, then if I put in 0.8 for my factor there, I should have put in 0.8 c squared here. 0.8 squared, 1 minus that, and then square root that answer. So I got 0.6. So the actual process would have only taken 7.2 times 10 to the negative 7 seconds. So because those particles are moving very fast in comparison to me, I see them appear to go slower than I would have otherwise expected. That includes things like half-life reactions. So if a reaction would have only taken 7.2 times 10 to the negative 7 seconds, because I'm viewing it as if its time has slowed down, it appeared originally to take 1.2 times 10 to the negative 6 seconds. This could be important if you imagine that there's some sort of engineering going on, let's say in a nuclear reactor or something like that, where you need to know how many of these nuclear reactions are going to occur. Obviously, if you did the measurement with the particle at the higher speed where the rate appears slower and then you slowed it down, you'd be surprised to find out that you're getting more nuclear reactions than you would have otherwise thought. So there's an example of where time dilation might actually be observable.